Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 2, exploring data with tables and graph. But we're going to emphasize a little bit more on section 2.3. Section 2.3, graphs that enlighten and graphs that deceive. But the goal for us is to develop the ability to graph data using a dot plot, stem, and leaf plot, time series graph, Pareto charts, pie charts, and frequency polygon. So I hope in this video that's what we're going to focus on. But you're gonna stay there with us, and because as key concept in this particular section, we would introduce other common graphs that foster understanding of data. Okay. We also discuss some graphs that are deceptive because they create impressions about data that are somehow misleading or wrong. But you know what? I'm going to make sure that I go over this part on a different video. So the era of charming and primitive had drawn graph has passed. Technology now provides us with powerful tools for generating a wide variety of graph. So what we're gonna do in a different video also, after constructing these graph here manually, I would record another video where I would cover how you can construct those graphs using Excel. So, if for some reasons you missed my video on how to use Excel to construct a frequency distribution, cumulative frequency distribution, relative frequency distribution, and frequency histograms, feel free to check my last video about that. All right, so without further ado, let's talk about one of the very important graphs beside, that you can use to display quantitative data. It's a dot plot, right? A dot plot consists of a graph of quantitative data in which each data value is plotted as a point or dot. You can see these examples right here. Pulse rate of males, that's an examples of it. So that should be done above a horizontal scale of values. Dots representing equal values are stacked. Okay. Because you see, you can put them in their overlap. Okay. So, or that's representing equal values, they are overlap or stacked. So, what you need to see in these examples, you see, for example, it's easy to see how many 60. So for 60, you see you have one, two, three, four, five, six, seven. So that data set, in that data set, you have 760s, right? But you can count because the smallest data is in this data set seems to be 40, and the largest data is probably 105. So that's a best guess because you see there is one that further between 100 and 110 seems to be halfway, which is 105. So, very important to verify dot plots. Features of a dot plot, the display the shape of the distribution of a data, and also it is usually possible to recreate the original list of data values. So when you look at this dot plots, a lot of dots above a horizontal scale. So these data, we can reproduce a tables, a regular table with all of them. Let's see very quick in examples how to construct a dot plot. So what I'm going to do, I would copy and paste, so I can remove the second part because we're going to focus on only on this first exercise. So we have enough space. So In a graph like this one, the first thing to verify is identify the smallest and the largest number in that data set. So because you need to know the smallest. It seems like the smallest is 36, right? But correct me if I'm wrong. I feel like it's 36, and the largest number is 94. So you have the minimum in that data set is 36. It's always very important to do that because you know where to start and where to stop. So when I construct a very horizontal line, I know I'm gonna put 36 to 94. So what I'm gonna do 35. You know what? Can we do even longer than that, right? I'm gonna try to do it longer. Okay, I'm gonna start here with 35. I'm gonna go with 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, and we have right here 95. But in between, I know at least where I'm gonna put the first number. So what I'm gonna do is make sure I check for 36. I would assume maybe 36 is close here. I would put 36. There is one dot so far for 36. And now we can count again. Is there any data in the 30s? No data is in the 40s. So I would believe we are in the 50s. So I can start with the smallest one, but I can take it anyway. I see a 58. So I would assume 58 would be probably here. So I put a big dot that represents 58. I see a 56, probably 56 could be right here. So I put a dot to represent 56. Is there any other 50s? I see another 56. Now they are overlapping on top. I have two 56, so I put two dots. And we have no more 50s, right? Now let's go with the 60s. I see 160 right there. I put a dot that represents 60. Okay. 61, 62, 63. I don't take them in order, but I see a 64. So probably 64 would be right there. But I also see a 66, right? If we put 66 here, there is one dot that represents 56. And right, so I see another 64 right there. So 64 has two dots so far, and I see another 56 right there. So that's another dot. Well, there is another 56, that is third dot, right? We call it dot plot. Now, do we still have some in the 60s? No, let's go for 70s. I see a 76. 76 should be somewhere here. So there is one dot for 76. I see 78. Maybe I see 78. I'm gonna put 78 here. Well, it's a 78, another 78, another 78. Is there any other 70s? So no more 70s. We're gonna go for 80. Is there any 80s. So yes, I see an 80 right there. 80 come right here. And 84, yes, 84, um, probably close to 85. I see an 84, but I also see 82 right there. We're gonna have an 82. And what else we see? There is an 86. 86. We can put a dot here. 88. Maybe 88 would be down here. And now you have a 94. So 94 probably close to 95 right there. So we call this a a dot plot, right? So a dot plot is you choose a horizontal line, consists of a graph of quantitative data in which each data value is plotted as a point or dot above a horizontal scales of values, right? So that's what we do. We can see the concentration of data is mostly in two areas between from 55 to 70 and from 75 to 90. So that's where you have more data. Now, let's suppose I want to do the second exercise. With the second exercise, what I'm going to do is I would copy again, but this times I will remove the first because we're gonna do B. And okay, to do B, remember our goal is to do B, of course. We're gonna do the same thing. We're going to construct a line, a very straight line, in which we need to identify the minimum, that's help us a lot, and the maximum. What is the smallest data in the data set? We can see the smallest data maybe is 60. So 60 is the smallest data, and the maximum is 90, right? Is 90. Now we can go from 60 to 90. If I want, I can say 60, 65, 70, 75, 80, 85, 90. You see, I try to put them as far as possible. Here we just sketch that dot plot. So how many data in this 60? First of all, this is one of them. I see another 60 right there, so I can try to go faster on this because now you get it. I see 62. Let me put 61. I put 62 here. So we have a 62 right there. Okay, and we have another 62, so two of them very quick. I see a 64, so 64 would come right before 65. I see I done below 65, of course. Now let's go above 65, between 65 and 70. Is there any more 60? I see 66. So how about 66 here, one dot? Okay, we have and then a 68, of course. I'll put 68 right here, one dot. I saw 68. Now, do we have any more 60? Oh, in the 70s. 1, 2, 3, 4. 470. 1, 2, 3, and 470. That's great. And we also see a 72 right there. I see a 72. I see 74 right there. I see 76. I see 76, 1 and 2, right? So we see 1, and 2, 76. I see 78 twice, so 78 probably somewhere here. Twice, I see 78, 1 and 2. And I see 80. There is no 80, so I see 82 twice. If I put 82 here, and that would be twice 82, right? So 82, 82. Okay, it's better we cross them out. It makes it much easier for us. And I also see 84 once. I see 86 once. I see 88 once. And after I see 88 once, I see 91 and 2. So when I cross out, it's make it much easier for me not to forget any of these. So that's how we proceed to construct. We proceed this way to construct the a dot plot. Remember, the dot plot is a graph that is falls above. Okay, so it falls above the data. It falls above it. Okay. So hopefully this one really help and you can do more graph. But in the meantime, for me, I can continue to show you some other graphs that we can perform. So one of the other graphs we can eventually do, we call it stem and leaf plot. Okay, we're gonna learn how to display data beginning with quantitative data. Of course, we beginning with stem and leaf plot. So let's go for the next slides. The next slide is about stem and leaf. When we said about stem and leaf plots represent, a stem plot or stem and leaf plot represent quantitative data by separating each value into two parts. As you can see, usually we write it this way. So on the left, you have the stem, and on the right, okay, you have the leaf or leaves. So meaning, if I have a number, for example, 46, I can write the first digit as the stem and the second digit as the leaves. But if I have another data, 48, I don't need to put 4 again. I can only add the 8 on this side. So meaning I have 46 and I have 48. If I have another one, 49, I can just put now. If I have another number 49, I can just put a 9. If I have another number 50, so I put the 5 on this side and the 0. If I have 53, I keep the 5 and I add the 3. So that's what we call stem and leaf. The stems such as the leftmost digit and the leaf such as the rightmost digit. Better stems and leaves are often obtained by first round the original data values, right? So what you can see, this is a very simple example. It's exactly the same data pulse rates. Remember, we did that particular example for dot plots. We use the same data set, but now it's represented into you can see how many data is in the 60s. You see you have 60, 60 one time, two times, three times, four times, five times, six times, seven times 60. So we have seven 60s. Then you're gonna have 62, a lot of 62, a lot of 64s, a lot of 66, 68. In the 40s, you have 40, 42. In the 50s, you have 50, 50, 52, five times, etc. And you see also in the 90s, you have 90, 92, 94, 96 twice. Okay, so that's what we call stem and leaves. In terms of features, this Stemplot shows the shape of the distribution of the data. You can always go back to the original data set if you want. The sample data are sorted, arranged in order. That means we cannot skip from 40. You cannot say I'm gonna put the 50s first. No, put the 40s first, then you go up to the 50s. So that's very important. That's very important. So now let's see about these examples. I can eventually do it very quick in this corner. I'm hoping I can do. For A, let's do it here. The stem is on the left and the leaves on the right. So remember, you always need to identify the minimum and the maximum. So anytime you construct these type of informations, always look for the minimum and the maximum. So I feel like the minimum here is 54 and the maximum would be what? 98. Yes, so that's a very simple one. So now 98. Because the minimum is 54, the maximum is 98. So the data are from the 50s to the 90s. So I don't need to start from 10, 20. I'm gonna start exactly with the 550, 660, 770, 880, 990. So now, how many data is in the 50s? So the only data I have in the 50s is 54. So I'm going to put the 4 on the right. Now, do I have any more data in the 50s? No. The next one would be 6. I see 68. Do I have any other data in the 60s? No. Let's go with 70. Oh, I see 70, 70. That's one of them. I see 73. I can put it here. I also see 7, 6. Yep, 7, 6 right there. And we have also 7, 9. All right, now let's go with the 80s. I see 81. I see 82, 83. Do we have more in it? No, we're done. Now let's go with the 90s. We have only one 90, which is 98. So we call this one stem and leaf plots. Okay, stem and leaf plot, that's how we go with it. And the next examples we're gonna construct eventually would be B as in boy. As I said, again, here you need to make sure that you can verify what's the minimum would be for this data set, what is the minimum, and what is the maximum. So the minimum, as let's verify it, I think it's the 30s, right? So we're gonna consider it's 36. Correct me if I'm wrong. And the maximum, the largest number in that data set is 94. Now, again, when you construct your stem and leaf plot, make sure you leave enough space to do the stem and the leaves. Now, because the smallest number is in the 30s to 90s, so we need to start from 3, 4, 5, 6, 7, 8, and 9. Because from 30s to the 90s, so the first data we need to get rid of is 36. We have one of them, only one in the 30s. Do you have in the 40s? You can look at data set and verify if you have in the 40s. No, you don't have any in the 40s. So do not remove the 4. So do not add 0 on the right, because if you add 0 on the right, that means it's 40. So you don't have any 40s though. So on the right side of 4, it would stay blank. Now, how about the 5? The 50s. The 50s, I see 56. All right, I see 56, right? I see 56 twice, and I see 50. Do we have any more 50? 56 twice. Yeah, 58. I see it. 58. Okay, are we done with the 50s? About 60s. So for 60s, I see a 60. Yes. 64. 64 again. Okay. I see 66. Oh, another 66. Another 66. Okay. Now let's go with 60. No, and do we have more 60s? No, let's go with 70. 70, 76. That's the smallest one, right? 76. I see 70, 76. Do we have only 176? Yes, we have 78 once, twice, three times. So eight three times. Okay. Yeah, we're done with 80s. Let's go 60s up, 70s about 80s. 80s, I see 80 right there. Okay. I see 82. We must keep them in order. I see 84. I see 86. And I see 88. Yeah. And I cross them out to make it much easier for me to remember the last one is 94. So I only put a 4 to make it 94. That's how you proceed to construct a stem and a flood. I would leave the last one for you. All right. So as you can see in the second stem and leaf plot, even though we have nothing for 4, we would continue to do it. So in a different video, I would continue to graph, more exercises or more graphs, of course, because so far we only dot plots and stem and leaf plots, but we're gonna come back in a different video for time series, of course, and also time series. We're gonna do pie chart, bar charts, etc. So let's come back for this. You know what? How about we do time series in this one because I want to focus only on quantitative data, then come back for the qualitative data. So for the quantitative data, what we can do, okay, what we can do for the quantitative data, time series. So a time series graph is a graph of time series data which are quantitative data that have been collected at different points in time, such as monthly or yearly. So if you want, look at this graph, for example. So you want to know how many children that were born in a particular city from 1985 to 2010. So that's give you an idea. And all you need to do is connect dots. So if you had in 1985 2,000 children, in 1993 you have 3,000 or 1,000, so you're gonna represent them at the intersection between, at the point because you find the points between the axis, the x-axis point and the y-axis point coordinates. Sorry, so you represent it with a dot. Okay, so time series is a graph of time series data, which are quantitative data, as we said. That's quantitative because dot plots quantitative, stem and leaf plots quantitative, time series quantitative. All right, so we do it for for quantitative data that have been collected at different points in time. So features in terms of features for this reveals informations about trends over time. Let's go over a few examples. As I said, we may need to use it twice. Let's use it twice. Like, okay, you know what? I'm going to remove the second so I have enough space. Voila. Voila, voila, voila. I can just move it a little bit higher because remember, we must construct a graph. Okay, so what happened when we construct that graph, we're gonna do it. Or maybe I'll do one of them and let you to enjoy the other one. Okay. List below are women's median earnings as a percentage of men's median earnings for recent years, beginning with 1997. Listed in order by row. So that means if I go with 1997 on a horizontal axis that represent the years, let's go. If I do 1997, you know, let's suppose 1997 could be somewhere here, okay? Is there a trend? So how does it appear to be to affect women? Now, if I start with 1997, where would I'm gonna continue to? And it's another. In 1997, we had nine. We have 74.4 because they said listed in order by row. Okay, so that means 1997 was 74.4, 1998, 76.3, 1999, 76.5, 2000, 76.9, 2001, 76.4, 2002, 77.9, etc. So we're gonna continue that way. Now, how many years? If I start with 99, 97, where would I stop? All you need to do is to count the number of data here. We said that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 20, that means 1997 plus 20 give you 2017. So for me, starting here at 1997, I can say 1998. You know what? I'm not gonna put 19. How about I just put 98? Okay, so I said 97, 98, 99, 2000, 2001, 2002, 2003, 04, 05, 06, 07, 08, 09, 2010, 11, 12, 13, 14, 15, 16, 2017, right? Now, that's the x-axis. On the y-axis, we're gonna have another straight bar. In this line, we're gonna have those numbers. Now, we see those numbers goes, if you want to go with the smallest and the largest, I believe the smallest is maybe the 74.1. So we know we can start with somewhere here like 74, 75, 76, 77, 78, 79, 80. How far are we gonna go? 81, 82. Do we have any 82 somewhere? I have said 83. Do we have an 83? No. Okay. Much easier to do on Excel. Definitely, we're going to come back and do some of these exercises on Excel so you can see, or StatCrunch, of course, because StatCrunch is incorporated into Pearson's. Okay, 1997 corresponds to 74.4. I'm going to just put a dot for it like this. 1998 is 76. If I go 76, probably somewhere here. 19 and 76 also for 1998. Maybe very close, like this one. All right. And then 2000, you're gonna go a little bit further. Okay. 2174. So going all the way down. So if I connect those dots, I can go like this, like this. So now we go down a little bit. Okay. Then that's how we're gonna continue. 2001, 2001. Remember, this one is all the way down here. It's really down. 2001 is 77.9. I really, what I'm doing here is really sketch it. 77.9 would be somewhere here. Okay, then we can go like this. We go like this. And 80. So we keep going. I'm not sure I'm on the 80s for now. 81. Okay. 2006 is 80.1. So you go a little bit down again. As 2007, because 97, 98, 9, 2000, 2001, 2002, 2003, 2004, 2005, 2006. Yeah, we got it. Now let's go again for 80. 2007, we have an 80 here. And 2008, we have 79. It's like we're going down with 2008. Sorry, 2008. 2009, we go back to 80. 2010, we have 81. We go a little bit further. 82, sorry, 82. 2011, we have an 80. We go down a little bit. 2012, 12, 13, 14, 15, 16, 12. Okay. I believe, we're gonna just look at it this way. We go up again and going down. And yes, we are in the 80s and 82. Okay. 81 again. Yay. I think the last one is okay. So exactly this is how you proceed to construct a time series, but our goal is not to do it really manually. Thanks to God, we have technology. We need to use the technologies we know, especially those that are more affordable and accessible, like Excel, to construct more time series. Okay. So in the different video, we're going to come back to construct more graphs, especially the bar chart, pie charts, and Pareto to display qualitative data. If you have any questions, you know how to find me. Take care.